We don't come back again. H Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, H Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This is a secondary school session for out-of-school children. Hello listeners, my name is Adesomi Temitayo and I welcome you to today's English class on ACE Radio School. Today, I will be teaching you the topic conjunction. Conjunction is spelled C-O-N-J-U-N-C-T-I-O-N. I'll take that again. C-O-N-J-U-N-C-T-I-O-N. Conjunctions are words that connect other words, phrases, or clauses together. A conjunction is like a glue that holds words, phrases, and clauses together. Examples of conjunctions are and, but, with, so, and several others. There are three different kinds of conjunctions: coordinating, subordinating, and correlative conjunction. They each serve different purposes, but all working to bring words together. In this session, we will learn about the coordinating conjunction. For example, take a look at this sentence. I like cooking and eating, but I don't like washing dishes afterwards. In this example, and is the conjunction linking both cooking and eating. There is a second conjunction in this sentence, and that is but. In this sentence, but is linking the two statements. The first is I like cooking and eating, and then I don't like washing dishes afterwards. Next example. Sophie is clearly exhausted, yet she insists on dancing till dawn. Can you identify the conjunction? It is yet. Yet is linking Sophie is clearly exhausted and she insists on dancing till dawn. From this example, you can observe that with conjunctions we were able to join the sentences above to form complex sentences. Without conjunctions, you'd be forced to express every complex ideas in a series of short, simplistic sentences. Coordinating conjunctions. Coordinating conjunctions. Coordinating conjunctions allow you to join words, phrases, and clauses of equal grammatical level in a sentence. The most common coordinating conjunctions are for, and, nor, but, or, yet, and so. You can remember them by using the acronym FANBOYS. Yes, FANBOYS. I want you to write this down if you can. F A N B O Y S. FANBOYS. F is for, A is for and, N is for nor, B is for bat, O is for or, Y is for yet, and S is for sell. Examples: I hate to waste a drop of gas, for it is very expensive these days. His two favorite sports are football and tennis. Tahir refuses to eat peas, nor will he touch carrots. My dog enjoys being bathed but hates getting his nails trimmed. You can eat your cake with a spoon or fork. I am allergic to cats, yet I have 3 of them. I am a vegetarian, so I don't eat any meat. Alright, let's do a recap of what has been learned today. We learned that conjunctions are words that connect other words, phrases, or clauses together. Now, who will remind us of the 3 types of coordinating conjunctions studied today? Can we start with the acronym? Okay. Fanboys, awesome! So, can we list them now? For, and, nor, but, or, yet. And the last one, so. Very good. Now it's question time. I'd like you to listen attentively to the following questions and choose the option with the correct answer. Question 1. How many types of conjunction do we have? A. 1, B. 3, C. 4. I'll take question 1 again. How many types of conjunction do we have? A. 1, B. 3, C. 4. Question number 2. The coordinating conjunctions are dash in number. A. 9, B. 6, C. 7. Question 2 again. The coordinating conjunctions are dash in number. A. 9, B. 6, and C. 7. Question number 3. Which of these conjunctions should be used in the following statement? I am an A student, dash, I read and write fluently. A. But, B. And, C. So. I take question 3 again. Which of these conjunctions should be used in the following statement? I am an A student, dash, I read and write fluently. A. But, B. And, C. So. Send your responses as a text message indicating your name, gender, state and subject, that is English, to 070-363-03182. Take the number again, 070-363-03182. Alright, well done students for participating with your friends in today's English lesson. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until I come your way again, it's Adesomi saying bye for now.
This is an ACE charity initiative powered by Grand Force Foundation.
This broadcast is for secondary school students. Hello listeners, my name is Mrs. Oluwashina Teniola and I welcome you to today's mathematics class on ACE Radio School. Today, I will be teaching you factorization. I will explain how to find factors of numbers and simple expressions. Get your pen and notebook and let's get ready to learn. Factors are numbers that can divide through other numbers without a remainder. I'll take that again. Factors are numbers that can divide through other numbers without a remainder. For example, 8 divided by 2 equals 4, and 8 divided by 4 is 2. Therefore, 2 and 4 are factors of 8. Other factors of 8 are 1 and 8, because 8 divided by 8 equals 1. Do you remember your days in the primary school? How you recited the multiplication table? For example, the 2 times table is read out loud as 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, 2 times 5, 10, and so on. Now, 2 times 1 equals 2 tells us that 1 and 2 are factors of 2. Of course, 1 is a general factor of all numbers. Also, 2 times 3 equals 6 tells us that 1, 2, 3, and 6 are factors of 6. Can someone guess the factors of 10? Yes! 1, 2, 5, and 10 are factors of 10. Fantastic! What about factors of 20? That will be 1, 2, 4, 5, 10, and 20. 20 can be divided by all these numbers without any remainder. What about 3? Do you think it is a factor of 20? No, because when you divide 20 by 3, it gives a remainder. Great! Now, can we find the common factors of 10 and 20? Factors of 10 are 1, 2, 5, and 10. Factors of 20 are 1, 2, 4, 5, 10, and 20. The common factors are the numbers that can be seen as factors of both 10 and 20. Therefore, the common factors of 10 and 20 are 1, 2, 5, and 10. 1, 2, 5, and 10 are factors of 10 and also factors of 20. Fantastic! Let's consider this simple example of algebraic expression. Find the factors of 5ab. Quite simple. 5ab equals 5 times a times b. This simply means that 5, a, and b are factors of 5ab. Great! Find the factors of 2ab. Easy! 2ab equals 2 times a times b. This simply means that 2a and b are factors of 2ab. Great job! Let's find the common factors of 2ab and 5ab. A is common with 5ab and 2ab. That's right. B is also common with 5ab and 2ab. Correct! And A and B are common factors of 5ab and 2ab. Let's consider this interesting example. Find the common factors of 10ab and 20ab. Easy! 10ab equals 2 times 5 times a times b, or 1 times 10 times a times b. 20ab equals 2 times 10 times a times b, or 4 times 5 times a times b. Now, what are the common factors? The common factors are 2 times 5 times A times B. This is equal to 10AB. Therefore, 10AB is the highest common factor of 10AB and 20AB. Quite easily done. Well done, listeners. We've come to the end of today's session. We learned about common factors and how to find common factors in algebraic expressions. I would like you to try this as an assignment and send in your answers to this phone number 070-3630-3182. Type your name, age, gender if you're a boy, type male. If you're a girl, type female, your class, and the state you currently live in. I hope you have done that. Now the questions. 1. Find the common factors of 8PQ and 4PQ. 2. Find the common factors of 6MN and 3MN. Find the common factors of 6MN and 3MN. Okay, I'll be expecting your answers. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until next time, it's bye for now.
We don't come back again. Ace Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, Ace Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This secondary session is for out-of-school children. Hello, listeners.
Hello, sir.
My name is Ibrahim Mark, your Ace Radio School physics teacher. Welcome to today's physics class on Ace Radio School. Kindly get your book and pen ready to take notes. Today, we will study the topic power. The topic is what?
Power.
I will start by telling you a brief story about two boys. The boys, Tunde and Shewa, are great friends who enjoy doing things together. One day, Tunde suggested to Shewa that they should engage in a contest to know who was stronger. Shewa agreed. On the agreed date, they decided that whoever could lift a bucket of water to the top of the mountain opposite their house would be declared the winner. The contest began as agreed. It was a difficult task. But after 20 minutes, Shehu shouted from the top of the mountain, "I am the winner! I am the strongest! I have the power!" While Tunde was still halfway up and panting seriously. The word power means how fast you can get a job done. Another word for job in science is work. Another word for job in science is what?
Work.
Very good. Therefore, we can describe power as the rate at which work is done. In our story, Shehu got the job of getting to the top of the mountain done faster than Tunde. We can therefore say Shehu has more power than Tunde. Before we discuss power further, we have to understand what work is.
Mr. Mark, can you explain the meaning of the word work?
Thank you, Tolu. Work means the amount of displacement caused by a force when applied to a body. And the formula for work or work done is work multiplied by displacement. Can you remember what displacement and force are?
Yes, I can. Displacement is defined as a change in the position of a body, while force, which is push or pull, is applied to a body.
Absolutely correct. And the SI unit for work is joules. Joules is spelled Joules, joules. Now let me define power. Power is defined as the rate at which work is done. It is also defined as the time it will take for an applied force to cause a body to be displaced from its original position. Take note of these three words: the time, the force, and the displacement. Using Shehu as an example, the time he used is 20 minutes. By lifting the bucket, he applied a lifting force. By moving the bucket from the base of the mountain to the top, the bucket was displaced from one position to the next. Remember, we said earlier that force and displacement, when multiplied, is equal to work. Now, Shehu's power can be defined as the work done, which is the force multiplied by the displacement divided by the time he took to do the work. Mathematically, the formula of power is work done divided by time. The formula for power once again is work done divided by time. Remember, the SI unit for work done is joules, and the SI unit for time is second. Therefore, the SI unit for power is joules per second, which is written as uppercase J with a slash and then lowercase s, that is joules per second. The SI unit of power, joules per second, has a special name known as the watt. Watt is spelled W-A-T-T. So, we write the SI unit of power as joules per second, but we call it watt. Now let us solve an example. Let us assume the work done by Shehu to lift the bucket of water to the top of the mountain is 10,000 joules. Calculate the power of Shehu. The power of Shehu can be calculated by dividing the work done by Shehu by the time it took to perform the task. In this case, 20 minutes. Hence, Shehu's power is 10,000 joules divided by 20 minutes. But before we calculate this, we have to convert the 20 minutes to the SI unit of time, which is seconds. This is simple. All you have to do is multiply 20 minutes by 60. The new time in seconds is 20 multiplied by 60, which is equal to 1,200 seconds. Now that the time is in seconds, we can proceed to calculate the power. Shehu's power can now be calculated as 10,000 joules divided by 1,200 seconds, which is equal to 8.3 joules per second. Instead of saying Shehu's power is 8.3 joules per second, we can simply say his power is 8.3 watts. Apart from the watt, when the amount of power used by a person or equipment is very large, we can also use other units such as the kilowatt, which is 1000 watts, or the megawatt, which is 1 million watts. We have come to the end of today's class, but before we go, I'll give you some assignments. Kindly send your answers as a text message containing your name, your gender. If you are a boy, type male. A girl, type female. Your class, the subject, that is physics, and the state you currently live in to 07036303182. If you are ready, I am ready. Question number 1. Power can be defined as A. Ability to do work. B. The rate at which work is done. C. Inability to do work. Question number 2. The SI unit of power is A. Watt, B. Watt, C. Second per joules. Send your answers to 07036303182. I believe we had fun learning today. Till I come your way again on Ace Radio School, use your power to change the world positively.
This is an ACE charity initiative powered by Grand Force Foundation.